Ready to have your mind blown? Today we're taking a deep dive into some seriously amazing space facts.
Stuff that'll make you see the universe in a whole new way.
We've got a whole collection of cosmic curiosities ready to go.
It's incredible, right? How much we still don't know.
I know. It's like every time we answer one question.
10 more pop up.
Exactly. So to kick things off, let's talk size and scale.
Yeah, like just how big a riot things out there.
Because we all know space is big.
Huge.
But I have a feeling.
It's probably even bigger than we can wrap our heads around.
I think you're right.
So to get a sense of that scale,
Okay.
let's talk about UY Scuti.
UY Scuti.
It's the largest known star.
Oh, wow.
Now imagine this.
Okay.
You take our sun and poof,
Gone.
you replace it with UY Scuti.
Okay. This is huge already.
And this star is so massive that it would actually engulf Jupiter's orbit.
Wait, so Jupiter would be inside this star?
Inside. It's mind-boggling, isn't it?
That's insane. But how does a star even get that big? What's going on there?
It all starts with these massive clouds of gas and dust, mostly hydrogen and helium.
Okay.
Now, gravity does its thing, pulls everything together,
Right.
and as it collapses, the core gets super hot and really dense.
Like a pressure cooker almost.
Yeah, exactly. And eventually, all that pressure, all that heat,
Yeah.
it gets so intense that nuclear fusion kicks off, and bam, a star is born.
So stars are basically giant nuclear reactors just hanging out in space.
That's a great way to put it. And the bigger the star,
The more powerful.
exactly, more fuel to burn burns hotter and brighter.
Wow, and UY Scuti must be like the ultimate power plant then.
Oh, absolutely. It's burning through its fuel like crazy, which is why it's so much bigger and brighter than our little sun.
Okay, I think I need a minute to process that one. That's wild. But speaking of wild, let's move on to something a little closer to home.
Closer.
Well, relatively speaking.
Okay, I'm intrigued.
You know, I've always been fascinated by Venus.
Oh, yeah, Venus is a strange one.
Right. Especially that whole thing about a day on Venus being longer than its year.
Yeah, how does that even work?
Right. That's what I want to know.
It all boils down to Venus's crazy slow rotation.
Okay.
It takes about 243 Earth days for Venus to spin once on its axis.
So that's one Venusian day.
Exactly. But its orbit around the sun,
Uh-huh.
that's much faster, only takes about 225 Earth days.
Wait, so a year on Venus is shorter than a day on Venus?
Yep, you got it. Talk about a weird calendar system.
Imagine trying to explain that one.
Right, like, happy birthday, but wait, you already had one this year. It's backwards from everything we know.
Totally messes with your concept of time.
It really does. Imagine celebrating your birthday less often than you have your morning coffee.
Okay, that's a good one. Now that's a different way to think about time, for sure.
Right.
But speaking of surprising things, have you heard about the water on the moon?
Water on the moon.
Yeah. I always thought it was this totally barren, dry place.
Right, that's what we always see in the pictures.
Exactly. But apparently there's water ice hiding out there.
Oh, I've heard about this.
Yeah, it's tucked away in these permanently shadowed craters at the moon's poles.
Like little cosmic freezers.
Yeah, exactly. Frozen over billions of years.
Wow.
So even though the moon looks all desolate on the surface, it's got these hidden pockets of potential resources.
It's pretty incredible, right? And think about what that means for future space missions.
Yeah. I mean, water ice on the moon could be game-changing for setting up a lunar base or something.
For sure. Drinking water, oxygen, even rocket fuel.
It makes the moon suddenly seem a lot more inviting.
Definitely. It's like finding an oasis in the middle of a desert.
Absolutely. This deep dive is full of surprises.
That's space for you. Always throwing curveballs our way.
You mentioned earlier how space is full of mysteries, things that make us rethink everything.
Oh, yeah, there are tons.
What's one that really keeps you up at night?
Tough one, but I think I'd have to go with dark matter.
Dark matter.
It's this invisible stuff that makes up like 85% of the universe's mass.
Wait, hold on. Most of the universe is made of something we can't even see.
That's the crazy part.
But if we can't see it, how do we even know it's there?
Because of its gravity.
Gravity.
Yeah, we can see its effects on things we can see.
Okay.
Like galaxies are rotating way faster than they should based on the visible matter we can see.
So something's got to be holding them together.
Exactly.
Right.
And that something, we think, is dark matter. It's providing the extra gravitational pull.
So it's like this invisible force shaping the entire universe.
That's a great way to put it. It's a bit creepy, isn't it?
Hmm.
Like an invisible hand we can't even grasp.
Totally. And the fact that we don't know what it is.
Right. It's one of the biggest mysteries in science right now.
Seriously, my mind is officially blown. Giant stars that would swallow Jupiter, a planet where a day is longer than a year, hidden water on the moon, and now invisible matter holding the universe together.
And we're just getting started. Space is full of these mind-boggling paradoxes and wonders.
Okay, bring it on. What else have you got?
Well, how about something incredibly dense, like unbelievably dense? Ever heard of neutron stars?
Neutron stars.
I think so. They're what's left after a star explodes and collapses.
Okay.
And they're so dense that if you could scoop up a teaspoonful of neutron star material, it would weigh billions of tons on Earth.
Billions of tons in a teaspoon.
You got it. That's denser than anything you can imagine.
I can't even wrap my head around that.
Hmm.
But wouldn't the gravity on a neutron star be so strong it would just crush you instantly?
Oh, absolutely.
Mhm.
The gravity there is so strong it would distort matter in ways we can barely comprehend.
It's like a realm of physics that's totally alien to us.
Exactly. But even though they're tiny, they're incredibly powerful. They emit these powerful beams of radiation that sweep across space.
Like cosmic lighthouses.
Perfect analogy.
So we've got giant stars, invisible matter, and incredibly dense objects. But what about something a little more, relatable?
Relatable. Like what
Like, what does space smell like?
you'd think a vacuum wouldn't have a smell, right?
That's what I would have thought.
But astronauts have reported that space has a distinct aroma. Not exactly pleasant, though.
Oh no, what is it like?
They describe it as kind of like burnt metal.
Burnt metal.
Yeah, or welding fumes.
Oh, yuck.
And some even say there's a hint of barbecue in there.
Barbecue. Really? That's not what I was expecting at all.
I know, right? Sounds bizarre, but there's actually a scientific reason for it.
Okay, I'm all ears.
It's all about the atomic particles in space interacting with spacecraft materials and spacesuits.
So it's like the smell of space exploration itself.
Yeah, you could say that. A unique cosmic perfume.
Not one I'd want to wear, though, if it smells like burnt metal and barbecue.
I hear you on that one.
This is making me rethink everything I thought I knew about space.
It's a wild ride for sure.
And we're not even done yet. I can't wait to see what other wonders await us in part 2.
Oh, we've got plenty more mind-blowing facts where those came from.
I'm ready for it. Back for more cosmic craziness.
Oh yeah, we're just getting warmed up.
I'm ready for it. Hit me with some more mind-blowing space facts.
All right, well, buckle up because we're going deep into the realm of black holes.
Black holes. Okay, so those are like the ultimate cosmic vacuum cleaners.
Right.
Just sucking up everything around them.
Well, not exactly. They're not really holes in the way we usually think of them.
Okay, then what are they?
Think of them more like regions of space-time.
Space-time, there's that word again.
I know. It gets a little trippy.
Oh.
But basically, it's where gravity is so strong that absolutely nothing, not even light, can escape.
So even light gets sucked in.
Yep, it's trapped. And that's why we can't actually see black holes directly.
Makes sense, but it's kind of creepy too, right?
Oh, definitely.
Yeah.
But even though we can't see them, we can see their effects on the stuff around them.
Okay, so how do we know they're there if we can't see them?
Well, let's say a black hole is pulling in gas and dust, right?
Okay.
All that stuff heats up as it gets pulled in,
Yeah.
and it emits X-rays.
Ah, and we can see those.
Exactly. We can detect those X-rays with our telescopes.
So it's like we can see the black hole shadow.
Perfect analogy. We're seeing the effects, even though we can't see the black hole itself.
That's pretty cool. But okay, here's a question.
Go for it.
Wouldn't a black hole just like eat the entire galaxy eventually?
Yeah.
If nothing can escape?
That's a good question, and a common one. But luckily, it doesn't quite work like that.
Ew, good to know.
Yeah. They have a strong gravitational pull, but it's not infinite.
Okay.
Think of it like a whirlpool in a river.
Oh, okay, I see.
It pulls things in, but it doesn't suck up the entire river.
So our galaxy is safe from being black holed.
Safe for now.
Black holes are seriously mind-boggling, I have to say.
No doubt. They really push the limits of our understanding.
Okay, enough black holes for now. My brain needs a break.
All right, let's shift gears to something a little less intense,
Thank you.
but just as awe-inspiring. Ready to talk about galaxies?
Galaxies. Yes. I love looking at those pictures, all those swirling arms and billions of stars.
They're like giant cosmic masterpieces, right?
Totally. But what creates those beautiful spiral shapes?
Well, imagine them as like density waves.
Density waves?
Yeah, regions where stars and gas are more tightly packed together.
Okay.
And these waves, they're thought to be caused by the gravitational interactions between all those stars as they orbit the galactic center.
So it's like a cosmic dance.
Exactly. And gravity is the choreographer.
That's so cool. Gravity really is the architect of the universe.
It really is, shaping everything, from planets to stars to entire galaxies.
And speaking of galaxies,
Uh-oh, what now?
did you know that our own Milky Way galaxy is on a collision course with another galaxy?
It's true. Mark your calendars, folks, because Andromeda is headed our way.
Wait, hold on, collision course. What's going to happen?
Well, collision is a bit dramatic. It's
Yeah.
more like a slow merger taking billions of years to unfold.
Billions of years. Okay, that's a long time.
But Andromeda's moving towards us at about 250,000 miles per hour.
That still sounds pretty fast.
It is, but on a cosmic scale, it's more of a graceful waltz than a head-on crash.
So what happens when they finally merge?
Good news is, the chances of our solar system getting directly hit are incredibly small.
I was wondering about that.
Yeah, galaxies are mostly empty space, so stars rarely collide with each other.
Makes sense.
But the gravity from both galaxies will start to interact and reshape both of them.
So our Milky Way is going to get a makeover?
Exactly. Billions of years from now, our familiar spiral galaxy will be part of a new, larger elliptical galaxy.
Wow, that's incredible to think about. Like, our galaxy is evolving, changing over time.
The universe is constantly changing, it's never static.
Makes our own little lives seem pretty insignificant.
In a way, yes, but also kind of freeing, don't you think?
Yeah, I guess it puts things in perspective.
Right.
Okay, well, since we're on the topic of our place in the universe,
Mm.
I've always wondered about the effects of space travel on the human body.
Oh, that's a big one.
I mean, it's such a harsh environment with no gravity, radiation, all that stuff.
Yeah, it's definitely not a walk in the park.
I can't imagine what it would be like to live in microgravity for months at a time.
It takes a toll on the body, for sure.
Like what kinds of things?
Well, one of the biggest challenges is bone loss.
Bone loss.
Yeah, without gravity, your bones don't have to work as hard.
Oh, right. They don't have to support your weight.
Exactly. So astronauts can lose bone density at a rate of about 1% per month in space.
1% a month. That's a lot.
It is, and it can make them more prone to fractures when they come back to Earth.
So space travel literally weakens your bones. Yikes.
Yeah, it's a serious concern.
Are they doing anything to try to prevent that?
Oh yeah, scientists are working on countermeasures all the time.
Like what?
Exercise is a big one.
Space workouts?
Yep. And specialized diets, too.
So future astronauts might be lifting weights and eating their veggies in space.
Pretty much. They're also exploring artificial gravity environments to see if that can help.
Okay, so bone loss, got it.
Yeah.
What about radiation? Isn't that a big risk too?
Definitely. Out in space, you don't have the protection of Earth's atmosphere.
Right.
So astronauts are exposed to higher levels of cosmic rays and solar radiation.
And that's bad because...
It can damage DNA and increase the risk of cancer.
So space travel is not for the faint of heart.
No doubt. It takes incredible courage and a willingness to face those risks.
It really makes you appreciate the sacrifices astronauts make to explore the unknown.
They truly are pushing the boundaries of human endurance and our understanding of the universe.
Okay, well, ready for something even more out there.
Lay it on me.
Let's talk about parallel universes.
Now we're getting into some seriously mind-bending territory.
I know, right?
Yeah.
But is there any actual science behind the idea of other versions of ourselves living in different realities?
It's a fascinating idea, and there are some theories that support it, like the many worlds interpretation of quantum mechanics.
Okay, break that down for me.
Well, this theory suggests that every time a quantum measurement is made, the universe splits.
Splits.
Yeah, it branches out into multiple versions, each representing a different outcome.
So there could be an infinite number of universes out there.
That's the idea.
A universe where I made different choices. A universe where dinosaurs never went extinct. It's blowing my mind.
It's a wild concept, isn't it? But it's important to remember it's still just a theory.
Right, we haven't actually found any proof of these parallel universes.
Yet, but who knows what the future holds.
It's exciting to think about all the possibilities. This deep dive has been amazing.
Glad you're enjoying it.
We've covered so much ground already, from black holes to galaxies to parallel universes.
And we've still got more to explore.
What other cosmic mysteries are we unraveling in part 3? Like we've traveled to the edge of the universe and back in this deep dive.
It's been quite the journey, hasn't it?
From supergent stars to those mind-bending black holes, and even, like, the idea of parallel universes.
We've covered a lot of ground.
It's amazing how much there is to learn about space.
And how much we still don't know.
Exactly. So for this final part, what do you say we explore some of the ways everything in space is connected?
I like that. It's easy to feel small when we think about how vast the universe is, but remembering those connections can be pretty grounding.
I agree. It makes you feel less alone out there in all that vastness.
For sure. So let's start with something that might surprise you.
Okay, I'm ready.
Did you know that the atoms in your body,
The atoms in my body.
Yep, they were actually created in the hearts of stars.
Hold on, you're saying the atoms that make up, like me, you, everything around us.
Everything. They were all once part of a star.
Wait, really? How's it even possible?
It's because of nuclear fusion.
Fusion, right? Like what happens inside the sun.
Exactly. So billions of years ago, these stars were creating all these elements in their cores.
And those elements.
They're the building blocks of everything we see today.
So when stars die,
They release all those elements out into space.
and eventually they form new stars and planets and like even us.
Exactly. Pretty amazing, right?
So we're all literally made of stardust.
That's a beautiful way to put it. It connects us to this grand cosmic cycle.
I love that idea. Makes you feel a little less insignificant in the face of all that vastness.
For sure. It's a reminder that we're all part of something much bigger.
Okay, so we're all stardust. What other cosmic connections are out there?
Well, have you ever heard of the cosmic microwave background radiation?
Cosmic microwave background. I think I've heard that somewhere. But
Imagine if you could tune a radio to hear the faintest whispers of the universe's birth.
okay, I'm picturing it.
That's basically what this radiation is.
You can hear the Big Bang.
Not exactly hear, but detect, yes. It's a faint afterglow of that incredible event.
So it's like a baby picture of the universe.
That's a great way to describe it, and it gives us so much information about the early universe.
Like what kind of information?
Well, by studying this radiation, scientists can figure out things like the universe's age, what it's made of,
Now.
even its shape.
So it's like a cosmic time machine.
You got it. Allowing us to peek back billions of years into the past,
That's mind-blowing. And to think, it's all around us.
everywhere.
Connecting us to the very beginning of everything.
It's a humbling thought, isn't it?
It really is. You know, as we wrap up this deep dive, I'm finding myself feeling a sense of peace with how much we do know about the universe.
I understand completely. It's awe-inspiring to grasp even a fraction of its grand scheme.
Right. There's still so many mysteries out there.
Oh, definitely.
But acknowledging how far we've come in our understanding is pretty incredible, too.
Absolutely. So for everyone listening out there, eager to keep exploring the wonders of space, I'd say the most important thing is to never lose that sense of wonder.
That's great advice.
Space is full of endless possibilities. It's a source of inspiration and fascination, so keep looking up at the night sky, keep asking questions, and never stop seeking knowledge.
Beautifully said. Well, on that note, we've come to the end of our deep dive into these incredible space facts.
Time flies when you're exploring the cosmos.
It really does. It's been a wild ride, from those giant stars to the very echoes of the Big Bang.
And remember, this is just the beginning of your own exploration.
There's a whole universe out there waiting to be discovered.
So keep exploring, keep learning, and keep looking up.